In this video, we're just going to do more examples with L'Hopital's rule. All right, just because we just learned it, it's pretty important. All right, just a quick review. What is L'Hopital's rule? If you're trying to find the limit of this fraction, and both the limits of the top and bottom are 0, or they're both infinity, you can simplify the problem by taking the derivatives and finding that limit. All right, so if you get 0 over 0 or infinity over infinity, you can do L'Hopital's rule. So this step here is where you declare you're doing L'Hopital's rule. All right, so example, I have this limit. This is one of the limits you could do without L'Hopital's rule, but let's say you didn't remember how to do that. Well, I'd go over here and I'd say the limit as x approaches infinity of 4x squared minus 6x plus 1. If I plugged really big numbers into this, I would get infinity. Limit as x approaches infinity of 3x squared minus x plus 7. If I kept putting bigger and bigger numbers from this, I'd also get infinity. So my two limits are infinity, which means I can do L'Hopital's rule. Again, it's important to declare that you're doing L'Hopital's rule. The limit's going to stay the same. The derivative of the top is going to be, I almost put 12, 8x minus 6. The derivative of the bottom is going to be 6x minus 1. And here's where one kind of goofy thing can happen with L'Hopital's rule. You can do L'Hopital's rule and the same thing can happen, because now if I look at the limit as x approaches infinity of 8x minus 6, I also get infinity. The limit as x approaches infinity of 6x minus 1, that's also infinity. All right, so this is another infinity over infinity, which means I can do another L'Hopital's rule. And that's going to give me the limit as x approaches infinity of 8 over 6. 8 over 6, its limit is just 8 over 6. And that simplifies to 4 over 3. All right, so L'Hopital's rule, you might have to do more than once. All right, every single time, make sure you're double checking those kind of limits of the top and bottom. All right, this one, just as a kind of aside, when you're doing limits of rationals like this, when the numbers are the same, the limit just ends up being the coefficient. So it would save you a bit of time, but doing L'Hopital's rule is not wrong. All right, here's another example. All right, so the first thing I would do is find the limit as x approaches 1 of x squared plus 5. And I see that's 1 squared plus 5 is 6. 6 is not 0 and it's not infinity, so this is not a L'Hopital's rule problem. This is actually just 6 over 7. You just plug in 1. All right, but this is one on the AP test they might throw in, because if you try to do L'Hopital's rule, you would get 2x on the top and 3 on the bottom. You get 2/3 as your answer. All right, but the correct answer is 6 over 7. You can't do L'Hopital's rule here because you don't get 0 or infinity as the limit of the top or the bottom. All right, so that's in this video. Just make sure you're always double checking that you can do L'Hopital's rule before you do it. All right, here's one that doesn't look like L'Hopital's rule at the beginning. Try to find this limit as x approaches 0, but 1 over 0 is 0, 1 over sine of 0 is 0, so neither one of these works. I can't plug it in, so what can I do? Well, really the only thing I can do, or think to do, is I have two fractions, let's put them together. So I can get a common denominator, multiplying the top and bottom of this one by sine, top and bottom of this one by x. My problem's going to become, let me write it over here. So my first fraction is now going to become sine of x over x sine of x, minus my second equation is going to be x over x sine of x, and combining that into a single problem, sine of x minus x, x sine of x. Okay. So now I have this written as one fraction, and whenever I'm trying to take the limit of a fraction, I'm always going to see if L'Hopital's rule applies. So the limit as x approaches 0 from the right of sine of x minus x is sine of 0 minus 0 is 0. And the limit as x approaches 0 from the right, I think I said left earlier, it's the right, x sine of x is 0 is sine of 0, which is 0. All right, so it is 0 over 0, so I can do L'Hopital's rule. So it's going to be equal L'Hopital's rule to the limit as x approaches 0 from the right. Derivative of sine of x is cosine of x. Derivative of x is 1. And on the bottom, the derivative of x sine of x, this is going to be a product rule problem because it's x times sine of x. So I keep the x, derivative of sine is cosine. Add, keep the sine, the derivative of x is 1. Now I try to plug in 0 again. Cosine of 0 is 1, so it looks like this might be another L'Hopital's rule. X cosine x plus sine of x. See, plug in 0, this becomes 0, sine of 0 is 0, I also get 0. So it is another L'Hopital's rule. So now this is equal to, using L'Hopital's rule. Derivative of cosine is negative sine. Derivative of 1 is 0, so that's just the top now. On the bottom, derivative of x cosine x is another product rule, so it's going to be x times negative sine of x plus cosine of x, plus the derivative of sine of x is cosine of x. Right. Now we try to plug in 0 again. In this case, it's actually going to work. If I plug in 0 into sine, I get 0. X sine of x is still 0, but cosine of 0 is 1. So I get 0 over 2. And it's fine if the 0 is on the top. My final answer is just 0. 0 divided by 2 is just 0. It's just kind of the most extreme L'Hopital's rule can get. You have to do a bit of simplifying first before you can even use L'Hopital's rule. You do it once, still doesn't work, you do it again, and you finally get your answer. Sometimes you have to do L'Hopital's rule 3 times, but in those ones you probably wouldn't have to simplify first. Alright, so here's one for you to try on your own. Kind of tricky AP type thing of this n up there, but n is just a number. Alright, replace it with a number and try it, see what you get. I'll show you the answer in 3, 2, 1. And the final answer you get is n, which is interesting. But if you do L'Hopital's rule, check the top and bottom, you get 0 over 0. Have to do L'Hopital's rule, derivative of the bottom, derivative of x is just 1, derivative of the top, product rule, and again it's just a number, so that it comes down in the front. You subtract 1 from the exponent. Technically you have to do a chain rule, but the chain is just another 1 because it's just the derivative of x. And then I plug in 0, this x goes away. Anything, 1 raised to the anything is just 1, so your final answer is just n. Alright, quick summary. Just remember you can't use L'Hopital's rule for every limit. We saw that one where if you tried to do L'Hopital's rule, you got the wrong answer. And just make sure to confirm those original limits separately to the side and then apply L'Hopital's rule. They don't want to see you do that kind of thing you kind of want to do, which is like equal 0 over 0 or equal infinity over infinity. Generally, you'll lose a lot of points on free response questions if you do something like that.